Okay, guys, welcome to our new topic today. We are going to be talking about waves, and today's video is introducing you to what are waves. We simply want to know some of the basic characteristics. I mean, when I say wave, a lot of you automatically go and think that's a wave, but that's not what we're talking about here. So we do need to come to a common language, and that means some of the things I'm going to say, you need to actually understand what they mean. So today we're just going to go through what a wave is. Then tomorrow we'll talk a little bit about the anatomy of a wave, what are its parts, and then we'll start looking at how waves behave. So we're going to start today with basically, what are waves? So when we're talking about this, what are waves? The first thing you need to know is that a wave is a disturbance that travels through space or matter. Now, a disturbance. What do we mean by a disturbance? Well, we're going to cover that one. Space or matter. Well, space is kind of easy. Space is out there. There's nothing in it. It's how sunlight travels. Remember, we talked about sunlight traveling on a wave with radiant energy. Well, a wave can go through space, or a wave can go through matter. If you think of it, your microwave goes through your food, causing it to heat up. So it can travel through space or matter, but what is a disturbance? And I want you to think about, if you're looking at this photo, what do you notice about the water? Is it smooth? Is it flat? Is it not moving? Well, obviously you can see that there's ripples on here. Those ripples mean it's been disturbed. All right? That basically, and here's the analogy. I want you to stand and think in your minds. I want you to think about a beautiful lake. There's no wind. There's nothing going on. And it looks like a smooth piece of glass. Well, how would you disturb that lake? Well, the obvious answer is you grab a rock, you chuck it into the lake, and you see a disturbance. That's all we're talking about here, is you take something that's perfectly smooth and level, something that is undisturbed, and you disturb it. You push on it, you pull on it, you throw something at it, and now it is moving, and it looks like it has waves. I'm going to demonstrate in real life some of that in a minute here. But I do want to cover the next piece of this. And that is, here's your smooth lake. Now, when this is undisturbed, when it's smooth like this, and it's perfectly level, we say that it is at equilibrium. That equilibrium means it's perfectly in the middle. We can also say that it's at a rest position, which means that it's not moving. So equilibrium really, if you look at a wave, if I draw this line here in the middle, and I draw a wave on it, do you see how that line is in the middle? That's what we mean by equilibrium. It's the line where half of the wave is above it, half of the wave is below it. So this line here is equilibrium. That's going to come up. All right. So, what causes a wave to form? All waves start by a disturbance in space or matter. What causes a wave to form? Throw something at something that's calm. Push on something. Pull on something. And here's really what's happening. The wave starts when the water particles, and we're going to use water as an example, are disturbed and move away from the rest position. Then they want to bounce back. So when we throw a rock in the water, what happens to the water when right where the rock hits it? Well, the rock pushes it down. So when we throw a rock into water, the rock is going to push the water down. Well, for every action, there's an equal and opposite reaction. If the rock pushes the water down, what's the water going to want to do? It's going to want to go back up. And now we have a wave. That's all we're talking about, guys. We're talking about taking a rock, tossing it into the water The water gets pushed down where the rock hits, and then it springs back up. That's a wave, a disturbance in space or matter. Now, what we do need to show here is that if I throw one rock, do I get multiple waves? No. One rock means one wave. And this is what we're talking about. What's the difference between a pulse and a wave? Well, a pulse is a single disturbance, and you have one ring that moves out. All right? One rock. Now, if I want to make a wave, I have to have like 300 rocks in my hand, and I have to keep throwing them into the water. It is a series of pulses that produces a repeating and periodic disturbance in the medium. Repeating means that it is a pattern. For instance, do you guys remember this from elementary? Ta, ta, tiki, ta. Ta, ta, tiki, ta. That is a repeating pattern. And periodic means it takes the same amount of time. I can't go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. You can't change the speed. It has to be the same. So if you want a wave, it has to be the same disturbance over and over and over and over again, and that produces a wave. Now, I can show you this, and I'm going to turn the camera slightly here. I can show you this by looking at this whiteboard. What I have on here is a pan of water sitting on an overhead projector, and if I pick up some water in an eyedropper, I can create a pulse. Now remember, a pulse is a single disturbance. I'm going to drop one drop of water in here. Watch the wall. And you can see that one wave came out. One dark line. Now there's some lighter ones, but those are reflections, and we'll talk about reflection later. In this case, it's just a single drop of water. And notice what direction it goes. It goes out in all directions. That's a pulse. One single drop. Now if I want to make a wave, I've got to make drops that go at the same pace. And now you can see now you see what it looks like on the other screen, and that is a standing wave. I'll roll this back over here. And so that's a wave. All right. Pulse waves. Now, another word we got to talk about here is the wave medium. The wave medium is the material in which it travels. For instance, sound waves go from my mouth to your ears. What are they traveling in? Air. A water wave. The medium is water because the wave is moving through the water. That's all that medium means. It just means what is it traveling through? And if you know what it's traveling through, we're usually pretty good. All right. We're going to jump here. I'm going to show you a simulation of waves. You got to see it on the screen, but I am going to show you a simulation here. So I'm going to phase out while I get this up. Then we'll have the waves, and then we'll go back to our normal presentation. All right, guys, here's the simulation. Basically, this simulation is on PhET simulations. You can play with it if you want. We will be using it as we go. As you can see, we have a beaded chain here. And the first thing I want to demonstrate to you is what a pulse is. To start, you can see we have an undisturbed medium. This undisturbed medium is at equilibrium. Equilibrium can be disturbed by creating a pulse through it. Now we have a disturbed medium with a pulse in it. So equilibrium is this line at the middle. We can always find it whenever we go to make a wave. It's always halfway between the highest point and the bottom point. A pulse is a single disturbance in the medium. So right now, I have my button set up to pulse, and we're going to create a pulse on the chain. Oh, that didn't look very fun, did it? So let's go down to, let's change this a little bit, and let's get it right there. There you go. Now you can see a pulse. It is a single disturbance. Move the tension down. See, single disturbance moves right down the line. Let's get this up a little bit. A pulse is a single snap of the rope, causes it to go out. Now, disturbance, on the other hand, remember, is a repeating and periodic. So if I click on this button, you can now see that it's going and making a pattern, and it creates a wave. That is the difference between a pulse and a disturbance, is that these are creating a wave. All right? All right, guys. Now, I did talk to you a little bit about how a wave moves, that it's energy that's moving, not the wave. So I want you to look at the green dots, and I want you to tell me if they're moving out the window or not. All right? So I'm going to hit play, and we're going to bring the amplitude down just a little bit. I want you to watch those green dots. They look like the beads are moving out the window, right? But that's not what's happening. The beads are actually not moving. They're only going up and down. The beads are not moving this way. And I can show you that. I want you to look at, and I'm going to hit pause and restart. I want you to watch this bead right here in the middle to see if it actually moves. So I'm going to hit start. And you can see what looks like it's moving, but let's go to slow-mo. Watch the bead here, the green bead. Is it actually moving? And the answer is no, it's not actually moving. It's actually staying in the exact same spot. It looks like it's moving because the wave gives that motion, which means if you throw a rock in the water is not actually moving except up and down. It's not actually rolling out away from that rock. The energy is moving away from that rock. In this case, the energy would be surfing right along this thing, and it would be riding the wave out the window, but the wave doesn't move. That's important to know. All right, so you've seen that. Now, I do want you to answer these questions and send them to me. In our simulation, what medium was the wave traveling through? A, empty space. B, air. C, a rope made of green and red beads. Or D, water. Please answer the question. Number 2, a pulse is a single disturbance that travels through a medium. True or false? All right, now I want you to remember that we are moving energy. If you remember, radiant energy travels on a wave. The wave is just the means to get the energy to move. All right? So the energy moves through a medium in form of a wave. That's how energy travels. We're all connected here. Make sure that you understand that the wave is not moving, or it's the energy that moves. And I'm going to show you this. We're going to go back to the simulation, and I am going to show you that the wave doesn't move. Just the energy on top of the wave moves. All right. There are really 2 types of waves in the world. We're going to spend a lot of time with this type of wave. This type of wave is called a transverse wave. That means in a transverse wave, the wave moves up and down. All right? So the wave is actually going up and down. But the energy is traveling left and right. That's a transverse wave. The other wave moves left and right, and the energy moves left and right. That's kind of obvious that but we're going to focus on this one. A wave goes up, a wave goes down, so you have the up and down motion of the wave, but the energy moves this way. All right? They're opposites of each other. They make an X. 12, Next question you need to answer. The substance that a mechanical wave moves through is called A vacuum, B medium, C propagation, D amplitude. And your last question is, which of the following is an example of a wave medium? Air molecules and other gases, water, a slinky, or all of the above? All right, that concludes this. Make sure you answer those 8 questions and turn them in on a Google Doc. That is your assignment. Have a great day. We'll talk to you tomorrow.